Hello everyone. I hope you can hear me. I hope you can see my presentation. So as Michelle said, I'm going to tell a bit more about security of your build and deployment environment. So this is not an application security topic as such, but it is very closely linked to application security. So I think that it's worth spreading the message to all security people and developers who are members of this OWASP community. Michelle already provided an introduction of myself. However, what I think is important, just two more things to add. So I'm DevSecOps practitioner, so I believe that developers' freedom and security can go well together. However, freedom doesn't mean that everyone can go happily without any security controls. I still believe that developers' freedom requires some security controls just to make sure that our ultimate product is secure and its integrity is on the right level. I'm also head of application security in a global company. However, what's important to mention that opinions which I'm presenting today are my own. If you want to follow me, you can just check my Twitter and Medium account. My handle is securityksl, and I will be also sharing my presentation there. My presentation has a lot of hyperlinks within it. So if you believe that you are interested in them, just feel free to go there and check the presentation. So just a bit of background why I'm even presenting on that topic. The reason is very simple. So historically, we had a very well-defined change management process. So it all started with change being requested, then we had some sign-offs, we had some security reviews, then the change was obviously developed by a group of developers, then we had a build process, peer review process, a lot of tests from different angles, so security, QA, unit test, integration test, UATs, and so on. And only after all these steps were completed, we went to our trusted administrator and we asked him or her to move this change to environment of our choice. So it was either QA or pre-production or production, dependent on our process. However, what is important that this process was very well structured with a lot of manual or semi-manual work. However, in agile change management process, it's a bit different. The reason is that we rely a lot on automation because we have a lot of changes which are happening frequently. So we can no longer rely on the sign-offs, manual reviews, and so on. We implement all of these things inside our pipeline, and we believe that our pipeline will do a good job for us. So currently, CI tool of your choice will do a lot of things for us, like testing, security testing, and some other things as well. It can also deploy things to production environment or any other environment of your choice. Obviously, that strictly depends on your organization risk appetite. So how do we make sure that our application is secure? So in this traditional model, it was relying heavily on the step that every process is manually reviewed. There is a sign-off that some folks from security or some business user will tell you, okay, that is something I approve, please proceed with that change. And we also rely on the fact that we have this trusted administrator who knows exactly what he or she should be doing, and he moves the change to production environment without any let's say, without any problems. Now in Agile DevOps, it's a bit different because most of the time we have everything as a code. So our code is our, let's say, crown jewel in this configuration, because if we can change the code, you can pretty much impact not only your application, but also the environment and even the pipeline configuration. So we need to rely on the thing that code is reviewed, so no unauthorized change are introduced, that tools can detect security issues or some other developers' mistakes, and that process is fully repeatable. So every build and every deployment is exactly the same. And probably the most important thing, that humans do not have a direct uncontrolled access to the environments. Because obviously, if we are building that thing and if we want our process to be fully repeatable, we cannot really introduce humans to it, because simply humans make things manual, and there is a chance that they will do this process a bit differently. So jumping to the main reason why I'm discussing this topic today is that obviously, if you can bypass or circumvent any of these steps, which you can see in the violet box, we have a problem, because if we are able to circumvent any of these steps, malicious insider or some developer who is not that familiar with security can basically impact the final shape and security posture of our application by modifying its configuration. So what is the problem statement? Is that for the last couple of years, we've focused a lot on topics related to security inside the pipeline. So all the tools like SAST, DAST, SCA, and so on. But it seems that we had a lot of situations when the pipeline itself wasn't properly secured. So when I started, let's say, researching a bit on that topic, I called some of my friends who are also in security industry, and I asked them, look, do you know any guideline how to secure a pipeline properly? And all the answers which I received were something like, you just need to limit the permissions, you just need to enable logging, and that was pretty much it, right? So by that time, there was no guideline how you should secure the pipeline properly and what are the things that you should care of. What is even worse is that some of teams, some of companies, they would do a configuration review, for example, of your CI component in the pipeline, but the problem is that it only gives a false sense of security simply because you are reviewing only one of the multiple components of your entire pipeline, right? So we are, for example, reviewing your CI tool, not paying enough attention to your SCM tool, to your, I don't know, cloud environment where you're going to deploy it, or to your artifact management system. So if you go to Google and if you Google CI/CD pipeline security, that's pretty much how it looked like. So in early 2020, it was very hard to find something about that topic. So you can only find some few articles here and there, just briefly touching that topic or different areas of that topic. Later on, it became more and more popular, and probably starting from Q1 2021, it became even more popular after SolarWinds attack, when people realized that security of the pipeline and integrity of all the artifacts is extremely important, simply because CI/CD pipeline can impact the ultimate shape and ultimate security posture of your product, of your application. So currently we have a lot of articles, tools, guidelines, which can give us some information. So even recently, a couple of new ones like SALSA or cyber supply chain risk management practices from NIST. That is something which is definitely worth having a look at. However, they are still quite high level, and what I'm planning to show in that presentation is some of the actual things which you can do right away and you can implement in your organization pretty much next week. So I think that the question that we need to ask ourselves is what can go wrong? So what are the components of, let's say, software development toolchain, and what bad can happen for each and every of them? This is a picture which is coming actually from that SALSA framework, which I totally recommend to you to read, because it also gives a nice perspective of what are the threats. But as you can see here, people from SALSA standard, they presented some high-level threats at each stage of software development toolchain. So now we can discuss, because you can tell me, look, but my pipeline or my toolchain looks a bit different because I'm relying on cloud, or I'm using CloudFormation or Terraform or Ansible or whatever else. However, these threats are quite common across all of these tools. So starting with the very first one, with the first problem, which impacts all the components in CI/CD pipeline, it's lack of basic security hygiene, which means that we are running the tools which are extremely important and extremely critical, which have access to multiple systems of our organization, but we forget about some really basic security measures, like patching these systems properly, like enforcing multi-factor authentication. We are exposing the systems to the internet. We are not monitoring them properly, and so on and so forth. The problem is that if any of these components, like SCM or CI tool, gets compromised, we have a huge problem. Because if we are relying on everything as a code approach, if someone has unrestricted access to our SCM tool, this person can literally introduce the changes on our production environment. Same for CI tool. If we are running a CI tool, usually your CI tool will have access to some of your secrets. This might be secrets to a QA or dev environment, but if attacker is lucky enough, he can get also secrets to production environment. So if we are not protecting these systems adequately, we may have a huge problem. What is even more problematic is that some of the systems, some of the well-known tools in the past were not that secure by default. So if some of you have worked as a penetration tester or red teamer in the past, you probably know that one of the first things you will be looking for is an unsecured Jenkins instance running in environment, because it was quite popular thing for companies to do, to run a Jenkins instance without any authentication in place, which pretty much results in remote code execution by default. Now it looks a little bit better, but as you can see, creating a setting where anyone can do anything is still something you can configure, right? So if I can recommend you one thing, just please have a look, what's your CI tool configuration, just to avoid it. So what are the recommendations here? Obviously, security hardening and basic security hygiene. So each of the main CI tools, but also SCM tools, usually gives you some recommendations how you should secure it adequately. So I include a couple of hyperlinks here for Jenkins, for GitLab, for GitHub, and so on. But most of the well-known software development tools gives similar recommendations. If they don't, just please use some your security instinct, right? So you shouldn't probably expose it in an unprotected way to the internet, and you should not make everyone an administrator. The second problem, or the second group of problems, is lack of branch protection mechanism if you're in your software source code management tool. So what is branch protection mechanism? It's basically a mechanism which allows you to enforce certain rules in your source code management tool. So one of the rules which you may want to enforce, and I would totally recommend you to do so, is that every pull request to your master branch or some other branch which basically triggers your pipeline needs to be reviewed before it's merged. So obviously the reason for that is that you want to make sure that no single developer can introduce changes directly to the production environment. Okay, so that's the high level idea here, that you just want to be sure that developers cannot modify your production environment in uncontrolled way. Okay, just a second. Okay, so that's it. Sorry for all the noises. My kids are running around, and that's a bit of a mess. Next thing, which is also quite important here, is that what you can do is, first of all, you can go to, let's say, your documentation and have a look how you can enable these things. But what you can also do is you can, for example, use some of the tools which can perform these checks for you. So for example, you can go to a GitHub app, which is known as All-Star, which allows you to enforce certain rules on your organization level. And again, I included some hyperlinks here, which you can just visit and you can just enforce these rules. Next thing is about principle of least privilege, which is not followed. So again, one of the basic things when it comes to security, however, it's not that well known when it comes to software development tools. What is the reason for that? The reason is that developers, they like to have a lot of freedom. They like to run with highest permissions possible so they can fix the problems why they occur. The problem is that if we have very broad permissions in our systems, in our software development toolchain, basically we are having a problem that people can do whatever they want, and then they can bypass all of the things which we defined previously. So for example, when we are speaking about this branch protection mechanism, if someone is running with administrator permissions on your SCM tool, this person can simply disable it. Same applies to every other component which you have in place. So again, some examples. If someone has excessive permission on CI tool, this person can literally modify all the configuration and start deploying insecure applications to your production environment. And what is even worse than that, probably this person can have unrestricted access to secrets to which your CI tool has access to. Same for cloud infrastructure. So why are we even securing the pipeline, and why are we even discussing pipeline security if we have developers with full access to your cloud infra? So that's yet another question that you need to ask yourself and basically ensure that if you are securing your pipeline, you are not giving any other possibility to bypass it. For artifact management tool, again, it's the very same case that we had previously. So we have our pipeline. We are doing a lot of stuff to ensure that our images and our artifacts are built securely. And if we have excessive permissions there, people can pretty much bypass everything we defined, and they can start uploading their own artifacts. So again, what are the recommendations here? Basic security hygiene and least privilege principle everywhere. So probably if you are some big organization, you don't want to give everyone administrator permissions on your SCM tool. You don't want people to have full access to your CI tool, and similarly with any other tool. So it's especially important for developers. So these developers, they shouldn't have access to the tools, so they cannot really bypass things which we defined there. If there is a need to have an emergency access, obviously you can create a procedures to do it, but you can also use some tools. So if emergency access is required, that is still possible. Again, at the bottom of the slide, I included a couple of hyperlinks which you can find interesting, as they are also providing some more details how you can implement that and what is important. Next thing is about improper segregation. So it's a bit related to what we discussed in the previous section, but it's more specific to CI tool permission. So what is the idea here? That you need to pay special attention how you segregate between workspaces, between projects, or between different environments, not only in your cloud infrastructure, but also in your CI tool. So what is the reason for that? Again, the reason is simple. So if there is a situation that you're running a single workspace, and then in this workspace, you're configuring your pipelines to all your environments, you're going to have a huge problem, because most of the times, or for certain tools, it means that people are able to reach secrets for higher environments. So for example, if you are not segregating access properly, your developer will be able to reach secrets from your production and deploy to production automatically. So if you don't believe that's true, again, just go to one of these two links, which I'm sharing at the bottom of the slide, because these attacks are really happening. So they're especially problematic when we are having a configuration where we run a pipeline on a pull request, because it's common in organization just to run a pipeline on pull request to verify if code created by developer is building successfully. So if we have the situation that we are executing pipeline on pull request, and we have a situation that we are storing all the, let's say, secrets in a single bucket, person who can run pull request can literally execute codes in our environments. So again, recommendations here, just please make sure that you're segregating access to the environments, that you're, again, it can be done by having multiple workspaces, it can be done by restricting permissions. Some of the CI tools have also a way how you can, let's say, give only access to specific secrets, to specific pipelines. So basically, you have multiple options you can do it, but just please make sure that you are aware of the problem and you can configure it however you like. And also, if you're running this configuration when you are executing the pipeline on pull request, again, just please reconsider that idea. I'm not saying it's bad. I'm just saying that please be aware that it's risky. So please make sure that your configuration is protecting you from this kind of attacks where someone runs some fantastic code and is able to reach your production environments. Last but not least, lack of integrity checks. So again, what we would like to achieve here is we want to make sure that the code that developer created in the very first step and which has been reviewed by his colleague is the same code which is going to run on the production environment. So basically, we want to make sure that we have some checks in place which will basically ensure that only this tested code is run on production. Obviously, these are some threats which you can see. So for example, we are creating an artifact, but then someone decides to upload some other artifact manually and run this artifact in our production environment. So we want to make sure that this is not happening. And that is why we need something which is called provenance. So if you want to know, it's a very interesting concept, and you should definitely check, for example, some standards and frameworks like salsa.dev. So that is a link which I'm including at the bottom of the slide. But the idea is that during the build process, we generate so-called provenance, which is pretty much a confirmation that this thing was built in a trusted CI, in a trusted tool. And it also gives some information what steps were conducted during the build. So what we can do on top of that, we can also sign that provenance and store it in a trusted location. And then when we are deploying this artifact to production environment, we can create a simple mechanism which is going to verify the signature and allow the deployment only if it's coming from the trusted source. So basically, if someone would like to bypass the pipeline and upload something from untrusted source, it's going to be impossible. So simple as that. Again, this is a huge topic. It's a very broad topic, but some of the hyperlinks in the bottom of your page can help you to get more familiar with it. So that's it. Just a couple of things which I want to mention. So first of all, security of the pipeline is as important as security in the pipeline. Security of your pipeline in your company, in your organization might be a bit different because obviously it depends on the organization size, on your risk appetite, or size of your development team, and on a lot of other factors. So basically you can tell me, look, Marcin, what you presented today is, it's not for me because the size of my team is limited to 5 people. That's fine, but you can still use some of the recommendations which are provided in this presentation. But if you have a huge organization controlled or which is a subject to some external regulations, you may want to consider implementing more and more of these recommendations. What is also important is that I would totally recommend to start with the basics, but then aim for the moon, which means that it's very unlikely that you are going to deploy all of the things over the weekend. So as a first step, I would probably recommend you to think about basic security hygiene. And only if you have that, if you are protecting yourselves from external threats, you should focus on the internal threats. So if you believe that you're secure from all the attackers which are there on the internet, that is good enough as a first step. And only then you can also think about all the other things which we discussed today. So that's it. Again, I will be sharing this slides on Twitter and probably on my LinkedIn. So if you're interested, if you would like to check some of the hyperlinks, please visit it and have a look. And I'm also waiting for all your questions on our Slack channel.